My name is Vesta, and I will be presenting on the project from school, the final project for the cancer and detection that professor told us about. So initially, the way I went about this, like I received my data and I tried to download the data and play around with it and see what I could learn from there. And I installed all of the dependencies that was needed to have my project completed. So previously, Professor put up this slide, one of the slide that he had working. So what I did was, ran all of these and, try to see what I could learn from, the data. So I made sure, I look at a read slide level, open slide, what it does. And I later on try to, download and my data set from the drive that professor shared. So again, I try to use the data gen tile level stuff just to learn about it because I heard it was highly efficient in selecting high, profile tiles, like tiles with very, very good and zoom. So I tried that initially in able to see how what it does, and I was able to select some slides and select a tile using a deep zoom generator with our size that professor stressed on, like the 299. And I started to play around and saw how far the deep zoom can go with each and tile extraction. So I later on extracted a tile with the deep zoom using a p size, and I got a lot of patches from that rotor code to be able to extract those tiles. And one of the issue that I face in extracting a tile, like I got lots of tile, but I don't know why the max came out all black. So it's like, yeah, I had to start again. So these are what professor wanted, like, the maxing, what you should see, and I was not seeing that. So it was one of those issues that I faced. So this is the actual start of my project. I had numerous slides, but I selected first to use this because I caught a lot of problem in trying to get all of the slides together, and I created a dictionary. So I did three type of models. So the first one, like I used the actual, slides, the patches, and the second model I just used the array that was captured within the implementation, of the patches. So I started with this one and I wrote this code to be able to use the dictionary and look through the directories that I saved because I saved three type of data. I saved the actual tumor, I saved the max, like positive max and negative max. That was what I intended to do first, but that did not go as expected. So this is the code that I use again because I use a lot of method to be able to see how I could extract, lots of tile and be able to make this work. Again, I started this one I saved for the max and I had problem as I said. So this code that I did, I started first with the and 91 tumor and 0.91, and I created a list to get the labels where I have like cancer and no cancer, and I use the for the mac factor like two times the level that is like each and down sample level. So it was like two times divided by the dimension of the patch because there was a lot of other ways to see what I could learn or what I could get from this data set. And I use a threshold for that, if it's greater than 80%. And I also use the next one and I set the threshold to the same 80% and be able to extract the patches that contains the cancer and I set the threshold to that. But what I found out was when I did it on level 3, yeah, I did it between level 2 and 3. there were lots and lots of, miss, like it did not detect a lot of cancer. It took a while to be able to see. And it was just a few, few that I was able to get out of the 531. And if you look in the array, you will see that, lots of zeros representing there was no cancer. And yeah, there was no, there was no max to match that. And the threshold, I changed the path. And so this is what upload, because I did it in a way that I should get at least, one uploader. So not using the array method, I use the actual and slides, the patches. And I had this and I call like, negative, positive, and yeah. So I reshaped my array that I did, like, try to get a train test and a split, and I use the ImageNet transfer learning. And what I found out with the transfer learning for the ImageNet was the accuracy was so high, which made me to understand that there were a lot of overfitting, maybe because of the zoom level, how deep I went, because I did it like 3 ways, with the deep zoom generator, without the deep zoom generator, and extracting the actual array elements for my prediction and stuff. Yeah. So if you see here, my accuracy was 99%, which I don't think was right. I believe there was some overfitting that occurred with the data set that caused that accuracy to be that high. So I did another model where I used the data generator to be able to do that, and I use a drop up layer, because I thought there was one thing I noticed, there was lots and lots of like oversampling, because most of the majority was like, no tumor detected, like those blank slides. So I did not shuffle because it was a lot of data, like thousands that I got. So I just used that. So I believe that was why, most of the prediction came up so high, because I did not filter. So it was one of those things. And once I used that for the training and accuracy, this is what I got. And it was so high. But as I said, you will see that, it was all negative cancer. It was because there were lots of negative in classes, and it was more than the positive classes. So that happened that, it got detected that way, given a threshold. And I use various threshold to be able to get a good and prediction. So I used this and I loaded the images. And what I did was I tried to use another method where I tried to augment the max. And I also did this, but this was so long. It took hours to have this completed. And once I was done with it, yeah, I had issues with that. At the end of it, I could not really get a valid and I could not get a valid prediction from that. Because when I did the yeah, so I'm sorry. So right after I did the augmentation, it multiplied to about 16,000, and it took like hours to have that done. So yeah, it was one of those things that I faced. But yeah, so next time if I'm doing this, what I learned from this is like, you have to get good data set, make sure that, you don't go too deep in a slide, because you will not just get every slide, as a tumor. So it's always going to be more negative than positive, which is not going to give you a good prediction. And yeah, so that was one of the things that I learned from this project, and how to work with image recognition. And it was a very good project, and thank you so much. Bye.